Section 9.6. Are combinations with repetitions allowed? In this section, we will discuss just one problem, but this problem is pretty tricky. So, an R combination with repetition allowed, chosen from a set of n elements, is an unordered selection. Guys, unordered means order does not matter. Is an unordered selection of elements taken from X with repetitions allowed. Please take a look at this example. Suppose X is the following set: 1, 2, 3, 4. Let us consider all three combinations with repetitions allowed. We list first all combinations with 1, 1. Here they are. Then all additional combinations with 1, 2. Done. Here we have all additional combinations with 1, 3 or 1, 4, all additional combinations with 2, 2, and so on. Looking at this example, it's pretty clear that even the question about listing all these three combinations with repetitions allowed is pretty tricky. But the main question in this section is the following. Find the number of R combinations with repetitions allowed for an arbitrary n and arbitrary R. Think about questions here.
For the last section, was that without the last problem we worked on with the Mississippi, was that repetitions not allowed or allowed in that case?
Very good question. Let us go back to this. Here, repetitions are allowed.
Oh, okay.
We are not talking here about combinations. We are talking here about permutations. We want to find all distinguishable orderings, distinguishable permutations of these letters. Over here, it's a totally different situation. We want to find all R combinations with repetitions allowed. Does this answer your question?
Right, and then by repetition, you mean like...
We have repeated elements.
Okay, good.
1, 1.
Okay.
So here we do not permute 4 elements. Observe that these triples are selected from the set that consists of 4 elements. You see the difference?
Right, and it's combinations because their order does not matter? Is that what?
Yes, order does not matter. Means 1, 1, 4 is same as 1, 4, 1.
Oh, okay, all right.
Maybe somebody can help me to deduce the formula. How to find the number of R combinations with repetitions allowed?
I think I might have it.
Yeah, okay.
Would it be, so your n elements in the set raised to the R power of R combinations?
Give me a second. So we raise n to R. Is this your answer?
I think so, yes.
Well, here is a problem. Let us try to apply this formula here.
Oh, yeah, never mind.
4, R is 3. 4 cubed is 64. But here the answer is, here is why. Please take a look at, for example, 1, 1, 4. Note that the order does not matter. When you raise n to R, order matters. But here order does not matter. Does this answer your question?
Yes.
So folks, it's a very tricky question. The solution is easy, but it takes some time to understand this solution? Here's one way to solve this problem. Think about n elements as about categories. Here is what I mean by categories. Please take a look at example 3. Our set consists of the following numbers: 1, 2, 3, 4, and 5. We want to find the number of 3 combinations with repetitions allowed. Here's how we do it. Each of the 5 numbers represents a category. Column number 1, category 1. Column number 2, category 2. Column number 3, category 3, 4, and 5. We divide these categories by vertical bars. And between the bars, we will put crosses if we choose the corresponding number. For example, we can represent the triple 335 in the following way: empty, bar, empty, bar, cross, cross, bar, empty, bar, cross. Here's why. We do not have 1, empty. We do not have 2, empty. We have 2 3s, cross, cross. We do not have 4, empty. We have 5, cross. So this triple 335 can be represented by the following string of vertical bars and crosses: bar, bar, cross, cross, bar, bar, cross. Similarly, the triple 1, 2, 4 can be represented by the following string of crosses and bars: cross, bar, cross, bar, bar, cross, bar. In other words, we have a 1-to-1 correspondence between our triples and the strings that consist of only 2 elements: vertical bars and crosses, which means for each triple there is only 1 corresponding string with bars and crosses, and for each string with bars and crosses there is only 1 corresponding triple. In other words, let us translate our problem about triples into the problem of strings that consist of only 2 elements: bars and crosses. By the way, may I ask a question? Suppose we have a triple. Let us consider the corresponding string with bars and crosses. How many bars does any of such strings have?
That'd be n minus 1
Well, in our particular case,
or 4.
4, obviously 4. 1, 2, 3, 4. How many crosses?
3.
So no matter which triple we have, we always have 4 bars and 3 crosses, correct?
Yes.
Now, the total number of elements is 4 plus 3. Here we have bar, bar, cross, cross, bar, bar, cross. The total number of elements is 1, 2, 3, 4, 5, 6, 7. Here we have 7 elements in this string of bars and crosses, and here we have 7 elements in this string of bars and crosses. Now, how many strings with 3 crosses and 4 bars do we have?
It would be 7 choose 3.
7 choose 3. Why 7 choose 3?
Because it's the number of combinations of bars and crosses of are 7 bars and crosses where there has to be 4 bars and 3 crosses.
Absolutely. Cannot be 7 choose 4. Is it 7 choose 3 or 7 choose 4?
Wouldn't they both be the same?
Absolutely. 7 choose 3 and 7 choose 4 are same numbers. 7 choose 3 is the number of ways to place 3 crosses in 7 positions. 7 choose 4 is the number of ways to place 4 bars in again 7 positions. It should be same. So, since we have a one-to-one correspondence between strings of crosses and bars and our triples, the number of triples here will be 7 choose 4, or which is the same, 7 choose 3. Maybe somebody can help me to generalize this approach. Suppose we have R combinations with repetitions allowed, chosen from n elements. What is the formula?
Well, there would be n minus 1 bars and r crosses, so you would have n plus r minus 1 up top, and then you would either have r or n minus r on the bottom.
So we have the choose symbol. What is the top?
N plus r minus 1.
It's exactly what we have here. 5 plus 3, which is 8, minus 1. Because we have 3 crosses here, in general r crosses, but 4 bars, not 5. 4 and minus 1. In total, we have r plus n minus 1. And then, so we have n plus r minus 1, choose what?
Well, either the number of bars or the number of crosses, so either n minus 1 or r.
Either n minus 1 or r. It's exactly what is written here. R plus n minus 1, choose r. Any questions?
Can you show how you use that formula again for the problem?
Yes, absolutely. So the formula is r plus n minus 1, choose r. In our case, r is 3. So we have choose 3. And over here, we have r. R is 3. And we replace n by 5. The answer will be 3 plus 5 minus 1, which is 7. Choose 3.
And so what does n equals 5 mean? 5 of what?
We choose 3 elements out of 5.
Just any 5 numbers, or just like 1, 2, 3, 4,
Well,
5?
here we have
Matter?
5 different numbers.
Oh, okay, gotcha. I got it.